back. So today we're just going to do some quick updates of things I've been taking care of. I'm pretty much getting close to finishing the torso here, except I needed to work on the microphone, and I wanted to use the actual little Geiger counter that's in the front here, which we call the microphone, but really wasn't a microphone in the series. In the series it was supposed to be like a Geiger counter, but we're going to use that as our microphone since it will be sort of at the right height for the robot. So we'll talk about how I incorporated the mic in that and set that up. And then we'll talk about a couple of things I moved around in the robot as far as boards and the EZB controller and another computer, Windows 11 computer and stuff like that. And yes, I also am replacing the waste motor. I've got to the point where I'm like, this motor is just too slow. We'll talk about why that was and how I sped it up. So lots of stuff to do today, so let's get started. All right, guys, so basically I've been sort of getting pretty close to mounting the torso on the main body. We're getting pretty close to finishing all that up and then testing out the head and everything and get everything hooked up. And then we'd be ready for some actual computer and software programming pretty soon. So the arms are going to be the last piece in the project, and those will come later as far as that construction. But I like to get everything functional and stuff like as far as the main robot goes first. But as I was testing all this stuff out, the waist rotation is, I think, a little slow. I thought it was, it was good enough. I was like, this is good enough. But as I watched the TV series and stuff like that, he moved very fast, left to right rotations, because there was a person inside, obviously, right? So, but I started rethinking, and before I get too far along, I thought maybe I should actually upgrade that and change it a little bit. So this motor right here is the one I currently have in the robot. It's a 24 volt motor that has a 35 per minute rotation speed. Now at 24 volts that would actually be fine, but the problem is I'm running a 12 volt bus. So when you're running a 24 volt motor on a 12 volt bus, you're actually cutting your rotations in half, right? Rotations per minute. So it's actually about 17 and a half that it's doing, which is not bad. You saw videos of it before. It went back and forth fine and everything, but it's not quite as fast as I'd like it. So I decided before I get too far involved to kind of upgrade that to a different motor. So I picked up this one right here, which is actually a 12 volt motor instead, which will be full 12 volts off the bus. And this actually is 100 RPMs speed. So what I could do with this motor is put a buck converter on it, and then I can dial it down so that one, it doesn't use so many amps, and two, to get it to the exact speed that I want to, because 100 is pretty fast. So that was probably just a little bit too much, but if I cut it down to maybe 60 RPMs or something like that, it's probably going to be close to where I want it, right? To have a nice quick speed, but not too fast, right? So I got this motor because I thought the three mounting pieces were identical in their size and location. So I'm like, oh, this will be a quick swap out. And then I completely forgot that I didn't even use these, right? I actually mounted this on top of the bracket using the holes on the tabs right here to hold it in. So this one doesn't have those same holes, so it's completely different as far as its mounting goes. And even if I use the three holes on the bottom here to mount it, the height is going to be different, right? This one's going to stick up higher. So we're going to have to redo our mounting that we did in there. Unfortunately, it's going to be a little bit of a work, but I think this would be a better motor to have in there. It's actually a little bit louder than this one, but I think if I cut down the rotations, it'll quiet down a little bit. But we're gonna try this and put this in just to see if it's better to speed up the rotation, because I don't want to have to pull it all apart later on when we're getting it all together and testing things and we're like, that's just not good enough, right? So we might as well just do it now and get it out of the way. This is part of this is what happens in these kind of projects where you build something, you think it's okay, and then you change your mind later and you got to do an upgrade to it, right? So luckily this is fairly easy. Remember, this whole middle section right here with this tower just comes right off here, off of these posts right here. And the only thing that's connecting this to the bottom piece are these main bus wires that you see right here. And I have all these quick disconnects, which is purposely why I use these quick disconnects, so I could just quickly disconnect these and then pull this whole thing off. So this whole tower will just come right off. So, and they're all labeled, so I never have to figure out which ones go with which when I put it back together. So very easily, you just flip down these little levers on the connectors, the wires will come out, and then I can pull this right off. So you saw the before, so this is the after, right, with the new motor, and you can see I can go very slow if I want to, just like it was before. So this was probably the speed it was before, somewhere around there. But you can also see I can go super fast now. That motor makes it much faster, right? So very, very fast now compared to the old motor, right? So that's fantastic. So even though it was a little bit of a backtrack pain to get that done, now that I put that in there, I'm much more happy with the speed of that. So this is just part of like building a custom item. You just never know, and you know, it's just one of those things you have to deal with, basically. So, you know, just FYI, you know, you will waste money building this robot, right? As you change your mind, do different things. Sometimes you have to experiment with parts to find out if it's going to work correctly. So it's not for the, it's very hard not to spend money and waste money sometimes, but you just have to deal with it, right? So can't use that motor I took out anymore, and I probably won't have anything to use for it, but that's okay. You know, it cost me like 70 bucks, but it's worth it in the end. I'll be much happier with the speed, and that's just some of the stuff you go through as you're building the robot. So for the voice recognition software, I wanted to have a microphone on the front of the robot, and the Geiger counter, that little device that everybody calls a microphone, it's actually supposed to be the Geiger counter on the robot that is right on the front of it, right, that has that little screen on it and everything, is a perfect place for a microphone. So, and that's what you can use these little Electret microphones on there. But I didn't want to deal with having to create my own board and all that kind of stuff. So what I did is I just bought this microphone off Amazon. This is a little Electret microphone. It has noise canceling technology in it, and so hopefully this will work. I did a test on the PC. I plugged it in. It's a really good pickup for recording and stuff like that. So I'm hoping it's going to work. I'm going to give this a try. But we have to incorporate this into this. So what we did is I broke off the top here, and you have to be super careful because I had to like really tear this thing apart to get this out, right? And you got the two little wires coming off the microphone. You got to be very careful you don't yank them off, right, or tear them. But basically, I've got the microphone separated now from the casing, and then the wires just run down this shaft right here. So I'll take the base apart here, and at some point along the line I'll cut the wires, right, so I can get this out, feed it through here and get this all set up, and then this part right here, the base, whatever's in here, will be inside the robot. And then it has a USB that plugs into the computer, which is going to be on the robot. So this should work very well. So far, it seems like it picks up really, really well, cancels the noise around it, and I'm hoping that's going to work for me just to talk to the robot. But we're going to find out, because we are going to set up some voice recognition. I actually have an Apple, the brand new Apple Mini that is being released next Friday, coming, that we're going to do some shortcuts on there because they have a good voice recognition, and we're going to test this microphone out with that little Mini, and see if it is actually going to work. So we won't know the full test until next week, but for today, we're going to get this all installed in the robot. And again, it'll just have a big long USB cable, as you can see, that goes down to the computer. In this case, it'll go onto the computer inside the robot itself. So, but that's what we're going to do. And so I'm just going to get this taken apart and then get this installed in this microphone. I got the bottom off right here. You can see underneath here, there's just this board which has the noise canceling technology basically on it. And it just has the 2 wires right here which go up to the little mic. So we're just gonna snip this right here, pull the mic out, throw away the whole unit basically, and then we're gonna install the mic into the microphone, and then that will solder these 2 back together, and that's pretty much it. We're ready to go. And then this little board here will just mount inside the robot, and then this cable right here, of course, will go all the way up to the computer inside the robot. So, and that's pretty much it. So let me get this all mounted, and then we'll see if it works. All right, guys, so here's the microphone itself now, all assembled, right? I put a quick disconnect right here so I could feed this through the front of the body and then connect it. And then this board right here, which you can see is powered right now by the PC because I have it plugged in, is the noise canceling part of it. And this will just be mounted inside the robot somewhere, right? So basically what we want to do now is just test it. So we're just going to leave it right over here. And we're going to go to Windows Sound Recorder right here. And we're just going to do a quick test of it. So let's start up the sound recorder and let's see what happens. Alright, this is just a quick test of this microphone. We're not talking in any loud voice or anything like that. We're just testing it to see how well it's going to pick up if this was on the front of the robot. Alright, so there is my voice recording. It did pick it up, and we're going to play it back. Alright, this is just a quick test of this microphone. We're not talking in any loud voice or anything like that. We're just testing it to see how well it's going to pick up if this was on the front of the robot. Alright, so that's really good. And you know, it may have sounded soft on the video, but you remember, it's just coming through my laptop speakers. I don't have any external speakers, and it's down here in the cabinet. So as far as the pickup goes, it picked it up really nice. So I'm pretty happy with that. And so once we get our Mac software, our little Mac Mini, and we get that hooked up and do a couple of the audio you know, voice recognition shortcuts, we'll set that up and we'll test it with the inside the robot here. So I'm going to mount this right now inside the robot. So I'm going to take this, mount it on the front here. Basically what I'm doing is I'm using a grommet that is a little bit smaller than the actual microphone. So this will slide into it, and on the back it'll just sandwich it between the body, and that's what will hold it in. And then if I want to, I can put just a little dab of like silicone sealer so this doesn't move, right? And it'll stay in place, right? And then it'll never come out. And yeah, I'll be good. But I'll have an actual functional microphone on the front of the robot. So there you can see it mounted in the torso. It just has that rubber grommet, which is just compression fit around it to hold it. And there's the wire coming out of it. So on the front, it looks like this. Okay, and once you get it all lined exactly where you want it, then that's pretty much it. Now remember, when the robot is assembled here, this is going to be, you know, sort of all the way up at this height, you know, just like kind of, let's see, it'd probably be around, yeah, right like in the middle of right here, which is a perfect height of where, you know, you're speaking towards it and everything like that. So it'd be like sort of right around here. So that's perfect, okay? So all I'm gonna do now is put a little epoxy right on that top of that rubber grommet right there, just a little bit around it, and a little bit on the aluminum shaft where the grommet, and that will just hold it in place. And you don't have to put much, just a tiny bit is fine. Then what I'm gonna do is run the wire up here and secure it solidly so that it never tugs on the wire coming out of the microphone, because those are very thin, tiny wires connected to the actual microphone itself, right? So we're going to make sure that those never get moved around or anything. So we'll mount that, and then the USB will just come out the top here and then go into the computer. So pretty easy. All right, so there's the final mounting there. You can see the little wire coming off the microphone. I just have a piece of this very sticky tape here that holds the wire in place so nothing tugs on it. You can see I've got some clear epoxy right around the microphone itself there, so that is not going anywhere. And then all I did is I put a couple of little standoffs on the board, attached those to the board, and epoxied the standoffs to the body. So the board is basically sitting up here on top of the arm opening. And then you can see the quick disconnect I have right here. As soon as the epoxy dries, then I'll connect it with the other quick disconnect, right, and that'll join it to the actual board. And then we're all set. The cable just comes out the top and then goes over to the computer for the USB cable. So the board's all mounted in here, and I don't have to touch anything. I even put a little, the cable there, like just squished it in the epoxy so that won't move either, right? So when this is all dry, this will be solid. I don't have to worry about it getting snagged on anything. All right, so our first step to get our audio out of our EZB is to get rid of the little tiny speakers. So if I pull this off here, that's just the power base. You can see here the little speaker that's on the bottom. This is the little tinny speaker we want to throw away because we don't want it to use it anymore. And what we want to do is get a 3.5 millimeter audio output coming out of this box so that we can hook that directly up to our sound system. And then when the EZB triggers some kind of a voice or audio file, it'll go through the EZB and then out to my sound system instead of going to this little tiny speaker, which nobody's going to be able to hear, right? So that's what we're after. But the main thing is when we create our soundboard inside the EZB software, or the ARC software I should say now, that when we do that, it's going to be able to be triggered by, one of these inputs depending what I'm doing, and then when it triggers it, it'll pass it through and go right out. So in order to do that, we got to open this box up here. When we open this up, you can see the little speaker right here. It's got two little terminals that actually just touch the two little terminals right on the board right here. And you would think that normally you can just then attach your wires here for your output, but you don't want to do that. And the reason you don't want to do that is because these two terminals are after the amplifier. So the amplifier is amplifying that and then going to these two terminals, which then come to the little speaker right here. So for the speaker part, this is easy. We're just going to pop this speaker out of here, and then that's going to be the end of that little speaker. We don't have to worry about it anymore for the most part. So it's just going to pop right out, and there it's out, right? No more speaker, so we don't have to worry about that. But what we want to do is attach a wire to a terminal on the bottom here, and luckily the terminals are here that we can do this to. So we're going to solder to this terminal right here, which you can probably not read, but this is a ground terminal right here, which is open. So we'll use that as the ground on our audio cable. And then we just need to attach either the left or the right channel, because it's just mono coming out of here, to this terminal, which is right here, okay, which is the audio before the preamp, okay? So basically before it gets to the amp, it'll just come right out here, and that should give us what we want. So we're going to just take a cable. We're basically just going to take an audio 3.5 cable, strip it down. We'll use the left or the right channel, doesn't matter really which, to go through here, and then it will come out, and we'll drill a little like notch in the box or something like that, and it will come right out there, and then we should be able to hook that directly to our sound system, okay? So if you're looking at the board from the Easy Robot, this is the bottom, this is obviously the top of the board, right? When you're at the bottom of the board and you see the four terminals right here, one being the ground, the other one that you're looking for is going to be the one all the way to the right. Okay, it won't be these at the top. And you only have these basic big ones on the top here, the two up here, and this one down here. And the one on the top here, what does it say? It actually says speaker right here. So this would be where you would think, hey, I can just attach a speaker right here, but it's not meant for what we're trying to do. We need to attach it before the amplification, and these terminals up here are after the amplification. And then that way what'll happen is the audio just gets passed straight through to the sound system, and the sound system will take care of the amplification from that point forward. In other words, it won't get distorted and screwed around with the little preamp, because that one is basically trying to use this extremely small little tiny speaker, right? So that's what we're going to do here. So what we have to do here is, and you can see the Easy B comes apart here, right here. This top part comes apart if you want to take it apart, but we should be able to just get a very tiny wire in there, and you know, make sure it's not touching anything else, and then do a solder joint on that, and then on the ground. So let me get that done, and then we'll give it a shot, see if it actually will do what we think it's going to do. All right, so I basically did those two solder points. I just took a audio cable, stripped the one end of it, two wires, and you know, one went to the one port, one went to the ground port, and I just notched out the case a little bit right here. I put a little wire tie on the other side of this so you can't pull it out, so it doesn't go past that hole there. And then for the power base, basically I just notched another little notch there, fits in like so, and that's it. Now I have my Easy B that can export sound directly to my sound system and doesn't go through that little speaker. And I popped out the little speaker so that doesn't, you know, make any kind of double noise or anything like that, right? So got rid of that little thing, just pops right out of the case, which is really nice. And that's pretty much it. So that's how you can connect your Easy B directly to your sound system. To test this out, we're just going to plug this into our audio system temporarily right here. And I'm just going to get a power. Which is actually just a battery, but just to power it up right here so we can hear it. So I just need to turn the robot on right here. Just plug them in here. And I'll turn down the background sounds so we don't have to listen to those. Okay. All right. And now we'll just plug in the little power supply, and it should boot up. And it has a little prompt. So you can hear that came through the speakers.
I have successfully connected to your network. Okay,
that's it. And that's this normal boot up on the Easy B with the voice on there. So that means this is working, right? The audio is coming straight out of the Easy B controller into my audio system. So we'll have to get this hooked up with the audio cables later, but that's our setup for that. And that's how you connect it directly to your sound system. All right, guys, so now we have the microphone in place, right, for our voice recognition. So at this point, the robot is pretty much finished as far as like the torso goes. The build is complete. I don't have anything else to do except, of course, the arms. But the arms are a completely separate, almost project by themselves because of the mechanics behind it and everything like that. Those I'm not, that's going to be near the end mostly. My next step really is to start getting these computer systems up and running, because that is really what's going to happen next. And this is where it's starting to get super, super complicated, right? There's a ton of research that has to happen, lots of programming of scripts, and just even dealing with MP3 files for the voice phrases and everything like that. But basically what we're after here is we've done a couple of things since we got the microphone now installed. And so here's the USB cable to that, right? This will actually plug into the computer, which is in the back here, which I'll show you in a second. But we've added a couple things. So first of all, thing we added is this little unit right here. This is called the EasyB controller. So it's made by a company called Cynthium, and they have corresponding software that goes with this and used with this controller called ARC, which stands for Autonomous Robot Control. It's incredibly powerful software. It's actually pretty amazing stuff, and you can do so much with it. But the nice thing about the EasyB here is that it has all these ports on it. We got serial ports, digital ports, UART ports. We've got so many ports on here and different ways that we can control things, whether it's a digital signal, whether it's just using a voltage signal, whatever it may be, right? So this basically will go with the ARC software, and this can then be connected to the PC on board here, which is just in a Windows 11 PC that has the ARC software on it running. And that's going to make him autonomous in a way where I don't have to control him from a laptop. Now, having said that, I want all my options open. I want to be able to control him autonomously by just speaking with voice recognition. I want to be able to control him with my Xbox controller, like I showed you previously. I also want to control him from a laptop. If I'm on a computer, and be able to just control him that way. I want all my options open. I don't want to limit myself. So this is where it's going to get super complicated. And same thing with the sound system. So right now I'm using the little MP3 trigger board on the top here, right? And that is using stored files on the little micro SD card that's inside that board. But I also want to be able to run voice through the ARC software because it has what they call a soundboard in it, which we'll get to way later, but when you see it, you'll understand what I'm talking about. And in order to do that, I have to run it through the EasyB out of the ARC software. Now, the ARC software actually can work with Arduino too, so there's all kinds of options here that have actually popped up in the last couple of years. When it first came out, basically it only worked with the EasyB. Now it works with all kinds of controllers, so you don't necessarily have to have the EasyB to work with the ARC software. That's how powerful it is. But in my particular case, it will work with this particular software, and I'll connect this to the computer. And then this is the thing I just showed you earlier, which is I created this direct out for the audio. So if I'm running audio through this, it can come out and this will go to my audio system. So now that's two ways to get audio out. You know, I'm either doing it through the trigger board, I'm doing it through the EasyB, through the ARC software, right? A third way I want to be able to get audio out is just straight Bluetooth. I want to be able to hook up a PC to this through a Bluetooth, or even a phone for that matter, any Bluetooth device, and run audio through it from the Bluetooth to the sound system. So what I'm going to be doing there is I have a board by Drock, who also makes a little Bluetooth pass-through board, basically, that will send audio to the audio system also. So I'll have 3 different ways that I can do it. And the reason I want to use the Bluetooth one is not just so I can connect my phone or a computer directly to it. I want to see what happens when I put the new Mac Mini inside here. So a second computer may be in here, the new Mac Mini that Apple is releasing this coming Friday, the November 8th. I can't wait to get it. The reviews on it are just through the roof as far as its performance, and I got it for $4.99. I got the base model because I'm not really running anything on it except for the ARC software and the file storage for the MP3 files. But the nice thing about the Apple is that it has in its voice recognition area a way to do very cool triggers that are much easier than the Windows, and you don't have to run it through the ARC software. It's just direct. But in order to use that, I would use straight Bluetooth coming out of the Mac. And that is what that other little board is going to help me do. So this may have 2 computers in the end on it, okay? Now the other thing I added is this little buck converter right here, which is the voltage coming into my EZB. So the way the EZB works is whatever voltage comes in goes out to all the different ports right here. So if you're controlling servos and things like that, you know, depending what you want your voltage to be, it's whatever comes in goes out. So this little buck converter right here is going to allow me to adjust this to whatever voltage I need in the end when I finally get to the point where I'm triggering servos and things like that. So I have that all set up and ready to go. So now let me show you the other piece on the back here. So I actually moved some stuff around on the back here. As you can see now, there's this little sort of mini PC right here, right? And this is an actual full-fledged Windows PC, believe it or not. These are these mini PCs that you see like on Amazon and stuff like that, okay? So very cool machines. This has actually a Windows 11 Pro on it, believe it or not. And I booted it up and set it up, and it's amazing how fast it is. I'm just like shocked. This little tiny PC is so fast. But what we're gonna do with this PC is we're gonna go into the BIOS and we're gonna make it so that power on it boots up by itself. So we're not gonna have to worry about pushing this button on the front to get the PC to boot up, okay? And then this PC will have the ARC software on it directly. And then all we're gonna do, because it is Wi-Fi also, we're just gonna remote desktop into it from my laptop when we wanna change anything on the ARC software. But the ARC software will be already on here running by itself. And so that's what is gonna make the robot more autonomous, because I don't need to hook up a laptop to make him run and do stuff, but I can if I want to. Because when I remote desktop into this PC right here, then it's like the, you know, my laptop is like has the software on it, even though the software is actually running on this PC right here. And what's nice about these little mini PCs is they run on 12 volt DC, which is my main bus in the robot, right? So again, because I decided when I was designing this way back in the beginning that the batteries down in the legs, right, those are two 30 amp hour batteries. That's 60 amp hours of voltage, right? 60 amp hours that it'll last. So far, I've been running this thing nonstop on these batteries. I think I'm only down 84%, which is, those batteries are just amazing how they've lasted so long. And I keep adding more and more stuff in here, and they're not draining fast at all. Like they're really amazing batteries. So those lithium iron phosphates are just amazing. But if you get a nice large amperage and you tie them together, I've got 60 amp hours, right, that I can pull from for those batteries. So that is just amazing. And I shouldn't have any problem with the amount of amps that this little PC pulls. And like I said, I've already, you know, set it up, booted it up and everything. And so I just need to get the ARC software on it and the MP3 files. But for the most part, that's pretty much it. I did put it in the back here because remember there's a vent back here. I can get my hands up, and I could also get a USB cable on here if I needed to. So it's in a really good location right here, right now. Now, the other thing I did is, remember I did the little stereo unit here. This is just a digital player for the background mechanical sounds of the robot, which are separate than the main voice sounds. And those come out these side speakers right here. Now, when I was looking at the boards, I also figured, hey, what if I just got another one of these little amplifiers right here, and then one of those little Bluetooth boards, and just ran that instead, because they make them where they can do a repeat, and that would save all this space, right? This big unit would go out the window. But the problem is that I noticed that all the ones I've tried, when you put it on repeat, the second the track ends, there's like a 1 or 2 second delay between when it starts up again. So the robot's mechanical sound should never stop as long as he's running. And so that was a little bit of a problem. So that's what's really nice about this digital player. When you have it on repeat mode, there is no gap at all. It just sounds like one continuous track that never stops. So I decided to leave this big unit in here, even though it does take up a lot of space. And just you know, stick with it because it works perfectly, and the track is just continuous and never has a gap in it. So keep that in mind if you're going to use one of those little boards to test it out first with a continuous track, because you may find that it has a gap. Yeah, and so that's pretty much it. Now I did add another board right here. This one is of course for the brain lights control. This board is just like this one right here, which is controlling the belly lights, if you remember from my previous video. So I need another one right here for the brain. It has a special brain mode on it set by these dip switches. But this one will be connected through a quick disconnect. It'll go up here, right? And then when the head goes on, that will be connected there. But I needed a place to put that, so that's been put on here. So really what I'm waiting for next to finish up the audio portion of it is this little Bluetooth board, which we're gonna mount. And then we're gonna connect all these audio connectors together, because remember, they have to feed multiple feeds coming into the audio system. So let me show you that. Remember, we've got two things that we have to feed audio into: the sound system itself to hear it, and the neon interface board to make it trigger. So because of that, we have multiple sources that have to go into these two things. So what we're doing is we're going to get these little audio splitters, which looked almost like this right here, where you have the male on the one side and two females on the other. And we're going to plug those into the main sound system, and then the neon interface board, right? And then we're going to feed both sources, the Bluetooth source and the MP3 sources, into here. So this is from the MP3 board, this is from the Bluetooth board, etc. And then the same thing will happen. We could have a third one actually that will feed in from the EZB, like with that output I was showing you, right? Because we need that to feed in there too. So there's multiple ways we can do it with splitter cables, but basically from the MP3 sources or whatever it may be, two can come into one here. And really, it's never going to be so that any of these are simultaneously running. It's always going to be one out of the three possible sources that are going to run into the system. So there should be no problem with any kind of interference or anything like that. We're going to test it out, of course, but that's our basic way that we're going to handle these multiple sources coming into a single sound system and a single neon interface. That's going to be it for a quick update on some of the things I've been working on. Like I said, the sound system is the next one to sort of wrap up, which we will do next week once we get that little Bluetooth board, and then we'll show you a demonstration of all the different sources as they come into the sound system. We've got the microphone taken care of now. And yeah, once we get that portion of it, what we're going to do is mount the torso onto the robot, just temporarily, to see how everything works and where the wiring is landing and everything like that. But that'll be pretty fun. And then we're going to start playing with the computers and the software, because we can't really button him up, in other words, put this torso on permanently, until we get the computers all functioning, running, and everything like that. So we still have some work to do to get the Windows 11 Pro computer running, the Mac Mini computer running in here, set up some voice recognition software tests, and then try it out. So that will be on the next video, which should be pretty cool if everything works out the way I think it is, where we're going to do some voice recognition. We're going to talk to the robot and have him talk back to us and respond, with phrases and things like that. So that'll be a lot of fun once we get to that. But we are waiting for our brand new Mac Mini that Apple just released to come in. So that's not till next Friday, at least, till that shows up at my door. And then we've got to set that up. And I'm actually new to Apple's operating system, so there'll be a little learning curve for me on that one. I'm used to the Windows systems, obviously. Like I said, it has a feature in it that's really could be really beneficial to use with the robot here. So we're going to try it, right? And then, yeah, I think that's about it for now. But we're getting to an exciting part of the robot build. It's going to get super complicated, like I said, but we're going to have a lot of computer systems running, and then start with the ARC software and get some basics running and going on there. And then what I'd like to do after that is test fit the head onto the robot. So I'd like to get, we got few connectors and wires we got to create, quick disconnects for the head. We have some power supplies and some voltage regulators we got to put in for that, but we'd like to get that on and just functioning and make sure that all works on the top of the robot here. So next time it should be pretty fun when you see the robot sort of almost all together, except for of course the arms, but he's getting close to getting into the real nuts and bolts of the actual control of the robot. And that is going to take, it's going to take a long time. Just creating all the phrases in the MP3 files is going to take, weeks and weeks of work, right? Not to mention programming it into the software and things like that. So lots more to come, but yeah, I'm really happy with where we are so far, and this is great for the winter time coming up, right? Lots of stuff to do when you're stuck inside, and this is going to be a great project for that. So, all right, guys. So as always, I hope you enjoyed the video. Make sure you subscribe, hit that like button, put your comments down below about this video, and I'll see you guys on the next B-9 robot build. Peace, guys.